The proper inflation of the airbag requires two reactions. These are the two reactions, and we're going to use these to figure out some questions. The first question is, how many moles of potassium nitrate must be included in the reaction mixture to consume the sodium produced by the decomposition of 1 mole of sodium azide? Well, the first reaction has 2 moles of sodium azide and 2 moles of sodium. But we need 1 mole of sodium azide. To do that, we divide by 2, everything by 2, and so we get 1 mole of sodium azide to 1 mole of sodium. For the second reaction, there's originally 10 moles of sodium to 2 moles of potassium nitrate. But we need to get the same amount of sodium as we got here. To do that, we have to divide everything by 10 to get 1 mole of sodium. And once we do that, we get 2 divided by 10, and we get 0.2 moles of potassium nitrate. And so that's our answer. Question number 2 is, how many liters of nitrogen gas are produced at STP if 1 mole of sodium azide and 0.20 mole of potassium nitrate react? In the first reaction, there's 2 moles of nitrogen azide and there's 3 moles of nitrogen gas. But we need 1 mole of sodium azide. So we divide everything by 2 and we get 1 mole of sodium azide to 1.5 moles of nitrogen gas. In the second reaction, we have 2 moles of potassium nitrate and 1 mole of nitrogen gas. But we need 0.20 moles of potassium nitrate for this question. To get 0.20, we can divide 2 divided by 10, and that gives us 0.20 moles of potassium nitrate. And we also divide nitrogen gas by 10, and that gives us 0.10 moles of nitrogen gas. And we add those together, we get 0.10 and then 1.5 of nitrogen gas. We add them together and we get 1.6 moles of nitrogen gas. Now we're going to find the liters of nitrogen gas. There's 1.6 moles of nitrogen gas, and there's 22.4 liters of N2 because it's at standard volume. So we multiply 1.6 by 22.4 and we get 35.84 liters of nitrogen gas. Question number 3 is, how does the pressure of the gas inside the airbag depend on the number of moles of nitrogen produced and the temperature inside the airbag? Well, nitrogen gas is what fills up the airbag, and to deflate, it has to go to a certain temperature. It has to decrease to release the gas.